Course and students, welcome back to our channel and Vinay Kumar Basics of Physics. Dear students, in this video we are going to discuss about the another important short answer question in the chapter of gravitation. This is the most important for 4 marks question, children. It was asked so many times in public examinations. The question should be like this: derive the relation between acceleration due to gravity and gravitational constant. What is the relation between small g and capital G? That is, we are going to derive in this case, children. So here what we know, small g is the acceleration due to gravity. Clear? And what is capital G, children? Universal gravitational constant. Universal gravitational constant. Small g is what? Acceleration due to gravity, and capital G is universal gravitational constant. So children, here small g value is 9.8 meter per second square and capital G value is 6.67 into 10 power of minus 11 Newton meter square per kg square. This is the value for capital G. So among these two, capital G is the constant value. That should be this much of value, 6.67 into 10 power of minus 11 Newton meter square per kg square. Capital G is constant everywhere is same, but small g is variable. 9.8 meter per second square can be considered on the earth surface only. Clear? So now we have to derive the relation between these two by using universal law of gravitation. So let's go for that. Dear friends, here small g and capital G both are different, and now we have to derive the relation between those two by using some universal law of gravitation. Children, here just let us assume that this is the earth. This is what? Earth, and its mass is capital M. M is what? Mass of the earth, capital M. Clear? On that earth surface there is one object. It is there, that should be here we are taken. Now it is the one object that should be having some mass M. Mass M is the S on the surface of the earth. Now we have to find out the relation between small g and capital G by using this concept. Children, here we know that definition of weight. What is weight? Weight is nothing but with what amount of force the object can be attracted by the earth. That should be called as its weight. A body can be attracted by the earth with certain force. That amount of force is nothing but weight of the body. That's why here when the body is on the earth surface, there is some gravitational pull on the body. Clear? Now that's why here I am going to write where is the object. Object is on the earth surface. Here now simply to lift any body from the earth surface, we have to apply the minimum force. That minimum force is equals to the weight of the body, children. That's why here what is small m? Mass of the body. And what is capital M? Mass of the earth. Now in this case, children, here there is gravitational pull. There is gravitational pull on the body. That should be taken as here F is equals to mg. F is equals to mg is what? Gravitational force on the body as mass m. And now we know, children, F is equals to G into m1 m2 by r square. This is what we call actually universal law of gravitation. When two bodies are separated by some distance r and they have some masses m1 and m2, then what, right? F is proportional to m1 m2. The gravitational force acting between the two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between the two objects. That is what we call universal law of gravitation. That's why here in this case I am going to take m1 is the capital M and m2 is what? Small m. What is m1? Capital M. Capital M is what? Mass of the earth. And m2 is equals to what? Small m. Small m is what? Mass of the body. And now here the distance between the object and the center of the earth. Center of earth is nothing but here r. Clear? The distance between, let distance between earth, center of earth and body is what? Capital R. Capital R. So here you have to think about the one thing. In this case m1 and m2 are separated by some distance r, but we are not showing any separation between the earth and object, but here we are saying that capital R is the distance between the center of the earth to the object. According to the definition of center of mass, the mass should be here located. That's why this point represents the mass of the earth and this is the mass of the body. If you can join this, then automatically that will give the distance between the earth and object. That's why here children, simply now here you can write according to the universal law of gravitation. Universal law of gravitation. So here the force between these two should be taken as F, and that should be here G into what is m1? Capital M. So F into G into m into m by r square. So this is the gravitational force acting between the earth and the object according to the universal law of gravitation. Now you can look at the equation number 1 and 2. Equation number 1 and 2. What you have to say, children? These two are represents the same gravitational force. That's why we can write from the equations 1 and 2. We can write like this. What it is? G or mg is equals to LHs are equal. That's why we can equal the RH also. Mg is equal to Gmm by r square. Here m is the mass of the body. Here mg are also mass of the body. These two are cancelled. Then what we get, children? G is equals to capital G into m by r square. So children, from the equation what we conclude? Small e is depends upon the mass of the body and distance between the body. What is capital M? Mass of the earth. Small g is depend upon the mass of the earth and distance between the body to the earth center. So that's what you have to say here. Small g depends on only m and r. And now here we are writing it. Therefore, G is not depend on the mass and size and shape of the body. So this is these 2 points we have to remember. Small g is depend upon the capital M and R, mass of the body and distance now. But small g is not dependent means what? Independent of mass of the body. Just you have to look at the equation. Is there any letter of small m? If small m is there, then only what you have to say? G depend upon the mass of the body. But in that equation there is no term of m, small m. That's why what you have to say? Small g is independent of the mass. At the same time, it is not dependent upon the size of the body and shape of the body. So children, this is the equation, that is the relation between small g and capital G. Okay, so children, I hope you understand. In our channel I am uploading the all IP intermediate videos and MSET videos.